Hi, my name is Caleb Cram, and this is my third internship with the GViz lab at Glenn Research Center. And it being my third time doing this, I wanted to kind of bring out something different than what I normally talk about. In the past, I've talked about the VR flight simulator for the Susan hybrid electric aircraft that I've worked on, as well as outreach tools for augmented reality with multiplayers and things like that that I've built in the past. However, in this presentation, I want to get a little more specific with one of the actual challenges I've faced that's been a little difficult to work around, but I've found an interesting solution. And that is spatially aligned, co-located augmented reality experiences. And that is having multiple people on different devices with the same experience, all aligned in the same room and all like lining up with each other. It's a surprisingly difficult problem to solve and something that I've really liked to sink my teeth into this last internship cycle, and I've managed to find some intriguing solutions too. So for a little project background, my job is AR and VR development with the Graphics and Visualization Lab in support of the EPFD project. My primary mentors are Dr. Herbert Schilling and Rich Reinhardt, as well as also honorable mentions Paul Catalano, who I get a lot of help programming with for like Unity things and C Sharp, as well as Calvin, who is just an awesome guy and helps out with anything he can help out with. The specific projects I'm working with is the Susan VR outreach system on mobile VR headsets, primarily the Quest 1 and 2. However, there's a PC VR version I've been working on in the background, as well as the HEM experience on all AR devices, and that's the high efficiency megawatt motor. And then also the W7 facility tour, which I've been optimizing for some VR functionality in the background. So specific project goals, my primary goals is to finalize optimizations of the Susan VR flight sim for Quest 1 and 2 devices. So it's fully optimized for mobile and polished up and ready to pass on for any other improvements they might want to make or polish up for release if they felt like it was at that point. And then also polishing up my HEM cross-platform multi-user AR experience. That's something I built this last internship cycle, which basically allows for cross-platform multiplayer augmented reality between anything from a HoloLens to a Quest 2 running pass-through, or even like a iPhone or Android phone or a tablet. Anything that's AR capable can run this experience and you can all interact with the high efficiency megawatt motor together in multiplayer augmented reality. Secondary goals I've had is to polish multiplayer WebXR content for release. I've had a bunch of WebXR experiences I've built, which is basically AR, VR, multiplayer interactive experiences that allow you to kind of pick apart something and kind of look at it together with multiple users. And they work on any device. Works on anything from a desktop computer to a AR, VR headset, like HoloLens, phone. Works on pretty much anything, and that all runs through WebXR. So it's all hosted in the web and then goes to the device. And I have those built for the James Webb Space Telescope, the HEM, the Susan plane, in a little interactive rover you can pick apart, and a variation of the W7 facility. Tertiary goals of mine is to build a HEM experience to the Groove Lab cave. And that is basically to try and basically get a version of the engine that we can see in the cave there. We recently got that up and running and working, so I'm going to be going back on site to finish that up. And then also building a W7 facility experience for the cave that allows you to kind of walk around inside of it and see the internal workings, as well as building a Susan flight sim to the cave with hopefully flight chair support. That is admittedly a stretch goal because I don't think I'll have enough time, but I'm going to try to because that'd be really cool to get working. Now, the actual meat and potatoes of the presentation is the spatial anchors and augmented reality. So the problem is the co-located multiplayer AR needs a way of tracking players' locations within a space so that they can be aligned. There has to be something to align them with. It can't just magically align everyone because it doesn't know where you are. So the solution I used is Microsoft Azure Spatial Anchors. It allows a spatial anchor to be generated and stored in the cloud or a local server from a device. And then that spatial anchor can be referenced by other co-located users for alignment. And this works on pretty much any platform, mobile phones, computers, headsets. It works on pretty much everything. Now, so for specific implementation that I used, I put it in my cross-platform AR experience for the HEM. And so this allows the first user that joins the room to create an anchor based off their space. And that goes to the server. And then other people go in, and any user that joins after that can then align off of that anchor if they so choose, at which point they all have a spatially aligned, co-located augmented reality experience where, their little avatars should all line up with their physical locations and their interactions should all line up spatially. Everything should look good. Now, here's a little video of what that looks like. Alrighty, so here is a demo of that co-located augmented reality experience for the HEM. This is the HEM right there. And this is between two HoloLens devices, specifically two HoloLens 2s. And basically, there's two of us in the GViz lab looking at the same experience with the same interactions at the same time. And we're able to see what everyone's doing to it. And it's all spatially located in augmented reality. Yeah, it's kind of cool. We get to kind of like pick apart the engine, kind of look at it and look at the internal workings a little bit and kind of learn a little bit about how it's put together and how it works, which is kind of the whole goal of that. All right, I think we're running along on time. So here is another little video. And this one is the rover experience I mentioned. This one runs on the web now. This video is done as native. However, this is totally web-based now in WebXR, but it allows all these different devices to interact with the same experience at the same time, including an iPhone all the way to a HoloLens or a Quest 2. So massive thanks to Herbert Schilling, Rich Reinhardt, Paul Catalano, also honorable mention to Calvin because he's just an awesome guy. These people have been great. I've loved working with them. It's been the greatest learning experience I've had, and yeah, I wish I could keep going with them, but they're just amazing people. But yeah, here's a little video on the outro. It looks kind of nice. But yeah, I've loved working with GViz Labs. It's been an awesome experience. And yeah, I'm looking forward to finishing up all these projects and hopefully leaving some cool stuff for other people to work on moving forward. If anyone has any questions, feel free to contact me at my NASA email. If I can, I'll give out my personal information as well. I don't really care. I'd be happy to talk to anyone. But yeah, hope you all enjoyed. Here's a little video of the Susan Bureau flight sim on the way out, just to keep things interesting. Thanks for paying attention.